So our next step is to use some of our statistical or central tendency vocabulary with histograms. So we can use a histogram to estimate the mean of a data set. Now, a mean can be calculated exactly from a histogram, but it requires quite a bit of mathematics that we're not going to get into. But we can, just from looking at the shape of a graph, estimate the mean and get pretty close to where that mean is. So the mean is the x-axis value where the bulk of the data lies. So let's look at these two examples here. Where does the bulk of the data lie in the left-hand one? Well, it's certainly to the right. It's somewhere over here. And if we wanted to go in the middle of that group of data, I'd say we're probably somewhere around 7 or 8. So you could say that the mean is about, let's go with 7. Just because there's a lot of data points to the left of 8, I think that the mean is going to get pulled a little to the left. So I'm going to say about 7. In the second example on the right, we see that the bulk is probably somewhere in this region. We sort of have two peaks that are competing, and so the average is probably going to be somewhere in the middle here. And so we could say it's going to be somewhere between 40 and 59, and so halfway between those is about 50. So I would say that the mean of the second histogram is probably about 50. Here's a couple of examples. Estimate the mean for each graph. So again, we have this example where you have two peaks that are sort of competing. So it's going to come probably about halfway between those two peaks, somewhere in this region. So that's probably in the 15 to 18 range, or maybe in the 12 to 15 range, somewhere around there. But I would say that roughly 15 is a good estimate. In the next example on the right, it looks like everything's really crowded on the left-hand side, and so the mean's going to be somewhere in the middle of that crowd. In this case, I think a good estimate would be about 8. Previously, when we talked about mode, you'll remember that it was the number that appeared the most often in a set of data. Well, now the data are binned together in these bins, so the mode is going to be the x value of the tallest bar on the histogram. Or in other words, it's the bar or the bin with the most number of values in it. So on this histogram on the left, we can see that the tallest bar has 5 values in it. And so the mode would be between 8 to 10 texts, according to the x-axis of this. And similarly, on the right-hand graph, we see that the tallest bar has 8 values, and so the mode would be 60 to 79. Outliers in a histogram will stretch the mean in one direction or another. And so here's an example. We have a histogram below, and we see this outlier sitting out here. The mean's going to be somewhere in the bulk of this data, and the outlier will stretch it a little bit to the right somehow. But outliers don't affect the mode. And we saw this again previously before we got to histograms, and it's because the tallest part of the graph is what it is, and having a little outlier somewhere, even if it's really far away, it doesn't affect the values that are coming up the most often.